Hi there, my name is Gabrielle Buck. Today I will be sharing a presentation on the study of climate change in agriculture. This is a geospatial study that explores how climate change is leading to an increase in invasive species and how that might be impacting agriculture. Take a minute and close your eyes and picture your favorite food. Are you thinking of pizza? Or maybe a tasty burger? Pasta? That favorite food you're imagining, chances are a part of it is sourced from a field, from some farm, in some place. Now imagine one day your favorite food just disappears. There no longer are tomatoes that make up your sauce on your favorite pizza, or grain to feed the cows for your burger. Agriculture is part of the foundation of our society. Without it, we wouldn't be able to survive. Over the last few decades, climate change has altered the average seasonal temperatures across regions. This change in temperature has allowed for the establishment of invasive species by creating habitats more feasible for the organisms to survive. Not only does the change in temperature impact agriculture production, the increase in invasive species poses a dooming threat to agriculture production. Invasive species finds a host to a lot of the agricultural crops, which not only damage the crops but can kill the crop entirely. Studying the impacts that climate change is having on agriculture production with the increase in invasive species will help bring awareness to the issue and hopefully inspire innovative techniques to help mitigate the inevitable spread and increase in invasive species. A little bit of background on what was the inspiration for this project. I spent years working with growers as a government worker. I tested their trees for viruses, trapped in their orchards for insects, and regulated their product to try and stop diseases and insects from spreading. My time working with these growers as a state employee made me see that invasive species are not something that is a fluke. Their presence is becoming more and more pronounced. Every year it seems there is a new insect that is threatening our agriculture. I have seen firsthand the damage and devastation that an insect can cause on a crop. I wanted to do a project that would bring awareness to how climate change is creating these new environments to allow for species that once were not able to survive in that environment are now able to establish a presence. This project will look at first how temperature has seasonally changed over the course of 20 years, then how agricultural land use has changed, then how vegetation health has changed, and lastly, how the dominance of invasive species has changed. Not only is the intent for this project to bring awareness, but it is also to light a fire under the concept of thinking outside the box in how we can manage invasive species with their growing threat. This project, my partner was the New York State Department of Agriculture. My contact there was Patricia Sujenga. I have known Patty for several years and used to work for her on several invasive species programs. Working with her on this project helped to give insight in the growers, the land, and the policy that is in New York State, specifically within Western New York. Her and I communicated mostly through email during the course of this project. She assisted in helping to establish a good study area and lent assistance in analyzing some of the results. She's excited about this project because it is so closely related to the work that they do within the Division of Plant Industry and the New York State Department of Agriculture and Markets. The study area for this project will be mainly based off of the town boundary of Wilson, New York. For data sets that were not large enough to give a good representation of the entire town, the county boundary of Niagara County was used. This region of New York State was selected because it contains some of the most agriculturally dense areas within the state. Additionally, its close proximity to Canada makes it more of a target for invasive species. The first aspect that was looked at was how climate change was impacting temperatures within the study area. Temperature trends for the past 20 years for Niagara County were obtained through the National Oceanic and Atmospheric Administration National Centers for Environmental Information. Temperature data was broken down first by year, 2001, 2011, 2020. Then they were broken down by seasons, winter, spring, fall, and summer. For the winter months, the months of January to March were used. For the spring months, April to June were used. Summer months will be considered July to September, and lastly for the fall, October to December will be used. Next, the average temperatures for each month within the season was taken. The years were combined based off season and then months. Using Microsoft Excel, the data was then plotted on a graph and the average temperatures on the y-axis and the month and the year on the x-axis for the four graphs. A linear trend line was added to be able to visualize the temperature trends for each season. Looking at specifically the winter months, Although there is a drop in average temperatures between 2001 and 2011, January 2020 is significantly warmer than January 2021. The same trend is observed for February-March. March shows a trend of continuous average temperatures warming throughout the span of 20 years. The winter months are some of the most important months to highlight because the warming of the winter allows for invasive species not native to cooler climates to be able to overwinter and therefore establish a presence. The next aspect that was looked at was land use. Using remotely sensed data from New York State Clearinghouse and NEARMAP to perform an unsupervised classification to show the change in land use for Wilson, New York, supported the notion that there has been change in agricultural land use. Moving forward, looking at the change in pixel counts gives a better idea of how the land has changed. Specifically looking at the years 2002 to 2011, between these years it shows 11.51% for water, 18.43% for forest, 13.36% for agriculture, negative 33.16% development, and negative 15.47% barren. Keeping in mind that a positive number in this instance means a decrease in that land use and a negative number means an increase in that land use. Therefore, between 2002 to 2011, there is a 13.3% decrease in agricultural land use. Since there is a 33.16% increase in development, it could be assumed that some of that land that went from agriculture got developed. This brings up the question as to why that land changed from agricultural land use. Did the growers retire? Did the profit from the land outweigh the profit from the crops? And if that is the case, why did production go down? Next, we look at the vegetation health. This was an NDVI analysis on the vegetation health between the years 2011 and 2021. This was done for Wilson, New York. Comparing the vegetation health from 2011 and 2021 gave unexpected results. The analysis shows that 2021 has healthier vegetation than 2011, which would be the opposite. The unusual results could be stemmed from the different data sources that each image was obtained from. For the imagery from 2002 was not used because for this imagery, 2002 was not used because the imagery contained one band, and to perform an NDVI analysis, an image with 4 bands is needed. Since the 2002 imagery was older, it only contained one band source from New York State Clearinghouse. Although the comparison between 2011 and 2021 did not result in the expected outcomes, analyzing just the 2011 image of the NDVI shows that some areas that are agriculturally shows unhealthy vegetation. Lastly, evaluating invasive species change. Evaluating the heat map shows that the invasive species detections for Niagara County show that there is an increase in invasive species detections. For the years 2011 to 2021 across the county, there has been an increase in invasive species detections, especially when compared with before 2000 and 2000 to 2010. There is at least a small detection found in every area of the county. Looking closer at the northern region of Niagara County, where most of the farmland is, there shows to be a heavy detection of invasive species in those areas. The hotspots in the northwest part of 2011 to 2021 map makes sense because of the proximity it is to Canada. This is also highlighted in the map showing 2000 to 2010. To present this project to the public, I choose to illustrate the information in Esri's story map. A story map is similar to a website, however it incorporates dynamic as well as static maps. This platform was chosen because it seemed to be the best medium to present the information as well as making it user-friendly. Unfortunately, it has not been able to be launched yet to the public because some of the analysis took longer than anticipated for the story map to be completed and launched to the public. The intent is to incorporate it with the New York State Department of Agriculture website so that the public can view it and understand a bit more of the issue and how they can get involved. Let's take a look real quick at the story map. This is a story map. As you can see, it's similar to a website where you can view and browse different areas. The story map contains information on the project as well as gives information about the partner and how users can get involved. Lastly, for more information regarding this project, please visit the links in the comment section of the video. This will contain a link to the story map as well as a link to the paper attached to this final project. Thanks for tuning in, and I hope you learned a bit about agriculture and how climate change is impacting it. Thank you.